Good evening, everyone. Wishing you a very warm welcome. My name is Taruna Chokse, and I am a part of Amdocs talent acquisition team. These are the exceptional times for all of us, but we at Amdocs are putting our best foot forward to navigate through the uncertainty and continue this exciting journey. So, before we begin, some quick notes. Right now, we have everyone on mute to avoid the background noises. Since this is a virtual event, we might face some technical hiccups, so please hold on to your patience and smile through the challenges. Please use the Q&A tab on your Zoom control panel if you have any questions for us. We'll be addressing them towards the end of this session. I would like to thank each one of you for joining us for this Talent Magnet webinar on importance of observability and monitoring in microservices. Today, we have with us Mr. Ankur Nima, who is the observability lead in MS360 platform with development, testing, DevOps, and automation experience of over 13 years. He is passionate about new technologies and is a mentor who loves to help others. So now, let's hear from Ankur.
Hello everyone, welcome to webinar on observability and monitoring. Myself Ankur Nema. I am a software development manager here in Amdocs. I am currently leading observability squad in Amdocs technology. We are a non-functional team who owns microservices development framework called MS360. This framework helps faster and standardized microservices development at organizational level. I hope every one of you and your family members are safe and are in good health. This is quite a challenging time ahead of us. Okay, so today's topic is around importance of observability and monitoring in microservices. So agenda for today will be first we will have brief introduction about monitoring and observability. Then we'll discuss about scope of monitoring and observability in various STLZ stages and benefit it brings. After this, we will walk through implementation at high level. Then we'll walk through some common pitfalls when implementing monitoring and observability. And in the end, we'll open the forum for Q&A and further discussion. Okay, so let's start. In current section, I will cover technical definition of monitoring and observability according to DORA and brief introduction around the topic. So what is DORA? DORA is DevOps Research and Assessment Group. It is a DevOps research program which represents 6 years of research and data from over 31,000 professionals worldwide. According to DORA, monitoring is tooling or a technical solution that allows teams to watch and understand the state of their system. Monitoring is based on gathering predefined set of metrics or logs. And observability is tooling or a technical solution that allows teams to actively debug their system. Observability is based on exploring properties and patterns not defined in advance. This is a very popular technical definition, and monitoring and observability usually go always hand in hand. Now let's do a deep dive. Let's try to understand in very simple terms. Monitoring and observability is set of tools clubbed together with set of practices to help our business and teams to gather information about following. Systems health. We want to know about our system and its health in various types of environment. Environment can be QA environment, development environment, functional testing environment, integrative testing environment. It can be UAT environment, and it can also be production environment. We always want to know health of our system. In production, it can be more critical. In UAT, it can be little less. In dev, it can be little less, but monitoring and observability is required everywhere. This data help us to know if everything is working as expected or there is something abnormal going on. Type of information we would like to know: is my system functioning as expected? Does my system have sufficient resources available to work normally? And so on and so forth. And when we have distributed system in play with tons of microservices or different system playing together in the field, knowing system health as well as health of individual pieces become more vital. Why? Because in distributed system, whole system does not break in one go, but part and pieces starts to malfunction. And if we don't get this information in time, it can escalate and it can break many pieces, and we'll get to know very later on when there is either loss of business or we get to know very late. So knowing systems health and any anomaly quickly is vital. Along with system health, we also want to know about system state. System state tells about experience from customer point of view. Customer can be internal customer, it can be external customer, it can be end users. Some answers we always want to know as soon as possible. Can my customer access the system? Is everything working as expected? Etc. How to get answers to such questions? In monitoring and observability, we use tools which provide data like metrics, logs, and traceability information. Now let's go over all these one by one. Metrics. They are simply a measurement taken from system representing the state of system in measurable way. For example, number of pending orders in my system, how many concurrent users are currently using my system, how many errors my system is experiencing or have experienced, let's say in last 15 minutes. So this data basically helps us to understand what is going on. Most common form of metrics measurement are counters, distribution, and gauges. Let's see what is counters. Counters are basically incremental numbers. So let's say whenever a user visit your system, you can increment the counter by one. Distribution is basically a measurement which can go up and down. Gauge is also similar. So distribution is very commonly used when we are dealing with web traffic. So let's say I want to measure some KPIs where I want to know in last 15 minutes for 50th millisecond what kind of traffic I am getting. So these kind of data is captured using distribution. Let's move on to logs. Logs can be thought of as append-only files that represent the state of single thread of work at single point of time. Logs are used for capturing variety of data. And in microservices world, distributed logging is used for correlating logs of various services and help in understand interaction between various services which participate in a business flow. Logs also provide vital information which can later be analyzed for a variety of use cases like data mining, trend analysis, etc. Big giants like Facebook and Google use terabytes of logs data every day for various use cases like targeted advertisement, etc. I think many of you have experienced in past, as soon as you search something in Facebook or Google, you start getting ads in various platforms. How exactly this happens? This happens using the log data and interaction, which is basically picked up by the backend system. Automatic analytics is run and targeted advertisements are basically pushed to us. Now let's move on to traceability. Traceability is ability to trace user interaction or business flow in a distributed system. Traces are composed of spans which are used to follow an event or user action to distributed system. Trace data correlated with logs is very important in microservices architecture, especially because microservices is not a traditional architecture. Things are distributed, services can come up, go down without even warning. So when we want to basically figure out what is happening, if a flow is not working properly, where exactly it got broken, so this data is derived from a traceability system. All these things which I have discussed so far also help us to identify unknowns. For an example, traceability data can help us to predict system degradation early. And when we combine this information from logs and metrics, then we can identify root cause early. That is, we have identified an unknown in my system and averted any potential problem. So traceability is also very important when we are in distributed system. And in traceability, we have usually a component called trace ID and span ID. Trace ID is a unique number or primary key, we can call it, given to entire event. And span ID is basically associated by sub components which are interacting with the system. So for a given trace, we get multiple spans, and these spans can help us to identify what is happening. And this span can be searched in logging system to identify what all happened in the backend. Now let's move on to our next section, scope of monitoring and its benefit. So this is a typical software development life cycle. We start with development based on requirement we get from either internal stakeholders or external stakeholders. Then we develop our system. We do our we do basically unit testing and functional testing in this stage. Then we move on to functional testing. Sorry. So then we basically move on to functional testing and non-functional testing. Here, the overall system is tested together, and we see a whole system working together as a unique final solution. In development stage, we work on individual pieces, especially in microservices, and in functional testing, we do end-to-end testing, and we also do other type of testing like performance testing. Remaining two stages are user acceptance testing and production deployment. So this is kind of a delivery of what we have done in previous two stages. And monitoring is kind of required at monitoring and observability is required at each stage, and it brings various benefits. Let's go over those. So when in development, good monitoring and observability help us to deliver better quality code by providing feedback to our work via automation test. We write awesome automation test, and this test generates various type of data. This data can be analyzed by internal development team to figure out whether their continuous integration, continuous delivery is actually working or not. Continuous integration is a stage where you continuously, whenever you or your development team pushes a code, automatically build happens, test run, and you get the feedback. And when everything is done, you can actually deliver the code into next stage. When we move on to functional testing and non-functional testing, we get feedback in integrative environment and thus can catch any defect which escaped in previous stage early. And in this stage, monitoring is also used heavily to gather performance parameters as well. So you can put load on your system, and this will basically help to generate various type of matrices and logs that you can analyze. You can also get some trace data. You correlate all these things together to see if your system is working as expected or not. Moving on to next stage, monitoring and observability help us to get feedback from customer environment as well before actually going live. This is what we call user acceptance testing. This data also help us to get feedback around customer expectation as well. So customer has given us the requirement which we have developed before we go to production, and then customer realize something is not working what they have defined. This we can catch in UAT. In usually in this stage, we also interface with other third-party system. In bigger organization and bigger system, it is not only our system which basically plays. We have to interact with other third-party systems as well to give the final functionality which customer is desiring. So before actually going live in production, figure out what is happening and whether our system is working as expected along with other system. This is the stage UAT where we actually run all the scenarios and we gather lots of parameters, and then we get to know whether everything is working fine or not. And then when we reach to production, it becomes quite important in terms of monitoring and observability. It helps us to get operational parameters, it helps us to get feedback, and it also helps us to measure business metrics like key performance indicators, service level agreement, etc. Data gathered from production also lead to various type of analytics and thus generate further requirement which keep this wheel going. So from production we get new requirements, new enhancement, which again goes to this stage, and we keep working in agile manner. Now, good and effective monitoring along with observability process and tools helps in higher performance, higher software delivery. How? Teams can know about various business KPIs, various metrics, various parameters, and possible they also understand defects and they rectify it. And all these things basically help to gather various performance parameters early and when they are developing. So here monitoring and observability plays a key role. This timely feedbacks basically help us to keep track of our deliverables. And when we keep track of our deliverables and when we don't delay, we have higher software delivery. And higher software delivery improves organizational performance as a whole by meeting their deliverables and commitment. And this also helps to faster time to market. And with better quality software, we don't have to reach market fast. We also have to reach to market with a good quality code and good quality deliverables. That is what is very important. So we always want to have a high performing team. What does high performing team actually deliver? Answer is very simple, a good quality software. But in today's agile world, we need to deliver produce software at a very fast pace. In microservices architecture, this delivery takes another leap. It is not only done at fast pace, but also done in incremental fashion. It is not that you will going to deliver for months and then you deliver in one shot. Gone are those days. And this is why we have continuous delivery. To have a good quality delivery via continuous delivery, we need comprehensive monitoring, good and properly integrated observability solution, and mature technical practices. All these things combined together can give you continuous delivery very easily. In microservices world, this becomes quite important as each team needs to produce piece independently, which will be in the end make whole system work. So it also required to have robust technical practices in place. So far, we have walked through brief introduction about monitoring and observability. Now let's move on to implementation part. How can we implement monitoring and observability in our system? So robust monitoring is a result of collection of systems and layers such as logging system. It helps us to capture logs produced by our infrastructure and microservices. Example of one such popular system is ELK stack, which is Elasticsearch, Logstash, and Kibana combined together, which collect log, provide aggregation layer and visualization layer. Elasticsearch provides aggregation layer and Logstash, or we can also use other components like FileBeat, FluentBit, etc., which will capture our logs. And then Kibana basically help us to visualize all these things together. Now, logging will only generate data which is produced by our microservices. This is logging data, but we want to also generate custom metrics as well, because not everything is known to the general framework. For example, number of orders you want to capture, it is something only you know. So you have to instrument. So what is instrumentation? To make use of monitoring, we need to first instrument various part of our overall system. Most monitoring systems supports instrumentation library, which can be made part of our delivered code. This library is used to capture and collect relevant data and expose it to, for consumption by monitoring system. One such popular library is Micrometer, which can be integrated with popular framework like Spring Boot, and it also provides data to various third-party systems in open telemetry format. Now, once we have instrumentation and instrumentation is producing metrics which we want, and logging system is producing lots of log information, we want to correlate. Why correlate? We are in microservices world, and microservices different system are working together. Metrics and relevant data can be collected from application, underlying OS, and infrastructure layer. Distributed system and microservices are different from traditional system, and this requires correlation logic as well as combining the data together to actually have meaningful insight. And the sources of data can be multiple. Prometheus and Grafana are quite popular tool in this arena. They provide this capability. Prometheus help us to gather data from various sources, metrics, for example, from your micrometer library. It is a time series database. It collects all the data and gives you something called PromQL, which you can use to write simple queries and aggregated queries and different type of queries. This data can be visualized in form of chart, gauges, and etc. using Grafana. Now, for this, as I discussed before, we need to compute, right? So correlation can be done using Grafana and Prometheus. We can also do computation using Prometheus. So Prometheus basically spawns the two layer, and the very popular tool or standard which are used is open telemetry and open tracing. What happens in computation? Once we have required correlated data, we need to utilize computation layer to monitor the system to generate meaningful insight and data points, which tell us the state of the system and projections and trends that can help us to identify anomalies as well as behavior of overall system. Output of computation can be graphs, it can be alert, it can be trends, it can be gauges, which can help to gather insight and analyze the trend, and it can help us to take critical business decisions manually or in automated way. A very good example of automation is, if you are familiar with Kubernetes, we have something called HPA. It's a horizontal pod autoscaler. Data produced by Prometheus can help us to know there are, let's say, 10,000 orders are pending and I have only 2 pods running. I can use this data to automatically scale up my system. We can also use all the data we have produced and expose it for other third-party system as well. And for this, we use open telemetry and open tracing, which is a de facto standard format for producing telemetry data and tracing data. All these things, when combined together, basically uh, help us to have two types of monitoring implementation styles. One is called white box monitoring. In this, monitoring and observability signals are captured from real working system. We have got also another pattern called black box monitoring. Here, it is also called synthetic monitoring, and we try to simulate customer interaction in this type of monitoring, and it is done periodically and randomly. It basically mimic how customer will interact with the system, and this generates some result which is basically fed to the backend system, and we basically analyze how system is behaving. Now, after going through the implementation part, I would like to walk you through some common pitfalls which we must avoid when designing monitoring and observability for our business. This is quite important topic. We should never assume that a plug and play monitoring solution is available and we can just purchase it and all our problems will go away. This will never happen. When developing a system for monitoring and observability for our organization, we should be basically aware of all the nitty-gritties of our system. Third-party vendor will not be aware. So we need to be very much thorough, and we need to properly design each and every component. We need to do instrumentation properly, and then only a monitoring system or observability system will actually behave as expected. Second pitfall where we should not fall is we should not create a dedicated single person or 5% or 10% team who is going to be responsible for entire monitoring of our system. Monitoring and observability should be a practice of each and every developer. A dedicated team, if will be responsible, they might miss critical points, they might configure system incorrectly, and it will also lead to a single point of failure. Instead, we should design a system and we should basically design some standard at organizational level, and we should train various development team to use the system properly as per their requirement. And our system should be flexible so that other team can create various type of rules, dashboards to suit their requirement, and can gain most out of whatever we implement. Third thing, we should never try to do cause based alerting. This is a very common anti pattern in writing alerts and monitoring system. We try to attempt to enumerate all possible error condition and write alert around it. This can overwhelm a system. So imagine you have a, let's say, 10-15 member monitoring team, who L1 or L2 support team, who is working on the system, and they start getting too much alert, and they might not be able to efficiently handle them. So this is what we call cause based alerting. We should avoid it as much as possible. Instead, we should focus on symptom based alerting, where only alert you will only alert the end team when there is a user facing system is visible. User can be internal or external, or a predicted or it is predicted to have some kind of alert. For example, your system is getting degraded and there is a risk of losing all the working system, and service may go away. In that case, you should in that case only you should throw an alert, and you should alert the correct focal point. You should not send out a generic email to, let's say, 50-60 people in an entire department. This will basically defeat the purpose of alerting. You should send alert to correct focal and via multiple channels, not only one channel, so that any critical alert should not be missed. Next point, we should not try to create any perfect visualization. When building monitoring dashboards to visualize metrics, a common mistake is to spend a long time curating a perfect dashboard. This is similar to cost-based alerting mistake, which I have discussed before. In a high functioning team, a system under observation changes so fast that any time spent on curating a dashboard will be out of date very quickly before it is even completed. Instead, focus on ability for team members to quickly create dashboard or other set of visualization that fits the need is very important. You should create a dashboarding system where person can add, modify or remove dashboard quickly and efficiently based on their requirement. And it should not be a team's responsibility. We should train our team development team to create dashboard based on their requirement, and they should deliver these dashboard in a plug and play format to the end dashboarding system. Last but not least is non-focus logging. This is very important. Logging is a vital piece of tool which help us to identify various type of information, various type of parameters of our running system in the backend. But it can be abused very easily when proper attention is not paid. This can lead to not only problems faced by internal teams, but it can also lead to legal compliance issues as well. Because if you log information which you are not supposed to log, it can lead to violation of various type of privacy laws which are out there. Increasing it also increase unnecessary costs due to excessive logging, etc. To mitigate this, proper logging standard must be maintained and enforced at organization level. Development team needs to be trained and retrained on regular basis around these standards. Whenever logging anything, always keep in mind your operational teams. In the end, it is not our development team which will deal with log first when system is in any kind of environment, but it will be mainly L1 or L2 team or DevOps team at customer end or at our end, which will going to deal with these logs. So what we log should be helpful to our L1 and L2 team or other DevOps team to figure out the problem. We should also ensure that we have a documented service operating procedures and manuals that are in place to take action based on what we are seeing in the logs. I will also try to highlight two bad logging examples. For example, your development team has coded to log entire customer information as info, and this information is getting printed very regularly in the log. This can lead to serious GDPR issues and violations. What should be actually logged is customer ID or some kind of transaction ID, which can be actually taken from the backend system and give to right person with right authority, and they can actually extract this information from the front end system itself, because we have a CRM system also there, right, where you have all the customer data present. You don't need to log everything to log to get the information. Another bad logging example can be a developer is kind of whenever they are entering and exiting the various functions, they are logging it as a message. This is not something we should log as info. We should always log these kind of information as trace, so that when we are developing, we can change log level of our applications to trace and see all this data. But when we move above trace, we should not log these kind of irrelevant information. On a closing note, I would like to explain in Hollywood style importance of monitoring and how it can help in a high performing team. So I'm going to take example of Avengers. I hope everyone have enjoyed these series a lot. Avengers is group of superheroes which basically come into picture and save world from various type of disasters. But can they act efficiently on their own? Actually, answer is no. Here is a person who basically comes into picture. He is a Nick Fury along with his Shield headquarter, helicarrier and control deck, where they monitor entire world and provide input to Avengers to act on any kind of adverse scenario. So what I want to stress is good monitoring actually helps in having a high performing team and deliver results efficiently and in a very good way. So these are some references I would like you to take note of. Here you can find DevOps research data which I have referred. You can read about this DevOps DORA research here. You can also read about various type of what is difference between KPIs, SLAs and SLOs. And you can also look at Google architectural DevOps paper, where you can find lots of information around monitoring and observability. With this, I'm opening the forum for Q&A. So there is a question from Santosh Prasad. Are we using Logstash or FluentBit? It depends on the use cases. Logstash is a heavy system. It has got various features there. You can use various features of Logstash, but in current container driven environment, Logstash can be very heavy. So we can use FluentBit or FluentD, which is FluentBit, which is lighter in nature. It has got a small footprint. It can be packed easily and can be used to have efficient logging in containers. So another question is why Santosh has asked another question: why not using Prometheus instead of Micrometer, which can be collected easily with node exporters? Node exporter can only expose data of the node. You want custom metrics as well, right? And if you use Prometheus, you basically tie yourself to a particular vendor. When you use micrometers are a very general framework. It has got integration point with various third party tools as well. For example, let's say your org want to use Dynatrace, your org want to use Datadog, your org want to use something else. Then what will you do with the Prometheus implementation? So it's always better to use a library which can basically collect and expose data, and it can be collected by various type of third party system. So do we have any other question? So what are the monitoring methods? So Bhupendra Kumar Sahu is asking what are the monitoring methods. So monitoring methods, there is no as such method. It's a basically set of practices. We can use various type of tools to monitor our system, and it depends on the use case basis as well. as well. There is another question from Biswas Ranjan Biswal. Can we use New Relic instead of Grafana? Yes, we can use. So we should always create our system to be flexible, because there are also managed services coming into picture, right? And customer want to use managed service over they want to manage something on their own. So we need to create a system which can be extended very easily and has got a plug and play architecture. So there is another question, sir. I am a bit confused with what is microservices exactly, and can you please clarify? So I would like to first of all take you to a little bit few years back. We used to create system using Apache and WebLogic, and we used to create a very big jar. Entire system was developed by single big team, and they used to pack it together, and then they use EJB and other stuff, and they used to deliver it to production. This is what we call monolith. Monolith means big. Now what we do in today's world, we try to make it more decouple in nature. You cannot have a very big team which is working on a big system in today's world, right? You can take Amazon as an example. Amazon as of today deliver their code into production every minute. How they do it? They basically break down their entire system into small services which are kind of independent of each other but work in harmony. For example, in Amazon website, you want to place an order, you can go, you can browse the various products, and then you can see the rating, and then you basically select your product, move it to shopping cart, place order, and then you get the delivery. All these things can basically form small subdomains, and this is what we call microservices. So there is another question from anonymous attendee. I don't know the name. What log stack tools you recommend for production system for telecommunications system where transaction volume is used? So you can use basically any kind of logging system which has got scalability in build, because in today's world you want to scale up and down, right? So most of the logging tools which are available in the market have already scalability aspect embedded in them. You can use any tool which is kind of suits your requirement. There is no recommendation as such for production system or dev system what kind of tool you should use. Based on your requirement, you need to analyze. Based on your system's need, you need to decide what kind of tools or stack you want to use. Are we using pull or push mechanism for monitoring? It depends on the use case. If you are using Prometheus, it is a pull based mechanism. It basically goes and pull data from external system, and there are various third party softwares which use push based mechanism as well. And for push based use cases, Prometheus also has something called push gateway, where short living jobs can push their data and which will be collected by Prometheus later on. So there is a question from Kanan. How do you decide what needs monitoring? Basically, you need to decide and you need to understand your system well and what exactly you need from the system. And is that system critical? And can, if that system goes down, what will happen? All these questions you need to answer. Then you need to decide whether you want to monitor the system or not, and at what level you want to monitor. In banking system, let's say a customer is adding money to its, let's say, account. Not monitoring that system can be disastrous. So but let's say we can take another example. You have a service which only tells give let's say for example some advertisement to customer. If that system goes down for shorter time, it can be handled easily. It is critical but not that critical that you have to monitor it very heavily. So you have to basically take a call based on your requirement, whether you want to monitor it extensively and what kind of SLAs you want to basically maintain around the monitoring. So there is a question, is there any working system there employing all these? In MS360, we have a monitoring stack where we use all these systems and we monitor all our microservices in real time. So there is a question around observability. Can you please elaborate once more its purpose and problems it address? So monitoring gives us data from the current running system and defined on particular patterns, and there is a predefined data basically you collect in monitoring. Observability helps you to also identify unknowns by analyzing the data trend and patterns. Is AWS a microservice? AWS is a platform. It is combination of various services, and those services are combination of various microservices. So every big service in AWS is basically combination of multiple microservices working together. There is a question around which language we should know to work on microservices in a company. Microservice can be written in any language. A good microservice ecosystem does not care about a particular language. It can be combination of language communicating together in some or other way. For example, your two microservices, one written in Java, one written in, let's say, Go, one written in .NET, can communicate with each other using REST protocol, or they can also communicate via messaging. So there is no specific language which you need to learn to develop a microservice. So there is another question where a person want to know about monitoring aggregation, why when it is used, and flapping services. So monitoring aggregation is like, for example, you are you are sending count of number of orders you are processing. So this is at any given point of time you can basically list out how many orders which came into system. But let's say you want to know in last 15 minutes what were the total number of orders you got, and you also want to know how many orders from those count got processed actually. So this is what we call monitoring aggregation, and this aggregation data help us to do trend analysis. So there is another question, which one of the best and efficient to get the logs? We can get the logs from CLI and GUI. So yes, you can get logs. You can also write logs to your file system as well if you wish. But when you want to search that log and get some data, imagine the kind of CPU you need to analyze those data written in file system and the amount of RAM you will require. This is kind of unnecessary wastage of resource. So we need an aggregator and a search tool to basically analyze and search logs. AWS, for an example, provide dedicated services around log analytics and log searching. So is there any tool available to make sure that sensitive data is not logged? Yes, there are. All the logging tools do have this feature out of the box in many cases, but you have to set your rules, and you can also develop your own services. What you can do is you can basically use aspect oriented programming. Whenever the log are basically sent to the external system, you can analyze and you can implement those rules, and then you can mask the details like credit card number, government ID, etc. So there is a question: does working of this DevOps monitoring tool differ based on which cloud is used in the project? It can, if you are using managed services. If you are not using managed services, you can create your own standard stack and you can deploy in multiple cloud as well. In Amdocs, our systems are deployed in multiple clouds, and we have a standardized logging solution which is compatible with all the clouds. Some infrastructure level changes are required to be done, but they are usually handled at infra layer itself. So there is a question, what is Kubernetes? I'm not very clear, but I'm assuming you are talking about Kubernetes. Kubernetes is a container orchestration tool. It basically helps us to deploy our containers, and it maintains life cycle of entire container, like from spawning, scheduling, and then making it up, checking whether it is ready or not, and then serving the traffic. So there is a question, who monitor the monitor? Most of the monitoring tool basically can monitor themselves as well, and they have a fail-safe mechanism in place where before even they die, they basically alert if there is any such adverse scenario that can happen. So there is a question from Chandrasekhar. What parameters should we consider while migrating from monolith app to microservice architecture? First of all, you need to basically sit with the architect, and you have to first of all understand your entire monolith system. Then there are various patterns you can apply, like whether you want to break down the system based on the use cases or based on domain and subdomain. Once you have all this information in place, then you can basically break down your system and decide till how much level you want to break. You cannot break it too much, but you should not break it very less as well. Try to imagine your entire service can be maintained by one pizza team or two pizza team, like 5 6 people. So 5 6 developer, if they can maintain an entire service, that is a very good way to take a call. So there is another question, should we focus on absolute numbers or average numbers when collecting any type of metrics? So it depends on your requirement and what kind of parameter you are trying to match. In some cases, absolute number is quite critical. In some cases, average number is also fine. So there is another question, how microservices are related to managed services. So managed services is basically a service which is managed by someone else for you, and you basically combine multiple managed services together to make up your system. So from a microservice point of view, managed service can be a microservice for your system. So there is another question, can you throw some light on functional testing? Functional testing is basically a testing where you test functionality of your overall system. And non-functional testing, you test other parameters which are kind of related. For example, you want to test whether how many users can log into a system at any given point of time. These are non-functional requirement. But let's say you want to test whether the order is getting fulfilled properly or not. This is what we can call it as a functional testing. So there is a question, you mentioned some metrics keywords, how it is related to MS. Microservices can produce some custom data. You can call it as metrics. For example, number of orders, it is a number of orders coming into system, number of requests it is serving. So these are all what we call metrics. Metrics is basically a measurable counter or a measurable measurement which gives you some insight. So do we have any other question? I don't see another question as of now. So I can take only two more questions because the time is almost up. So there is a question from Naveen Kumar, for distributed transaction. if a service down in between and we lost, we hold the transaction, and how. So it depends how you are actually designing your system for transaction. In a distributed transaction, let's say your system is moving from one to another, you must have some buffering in between, right? You can use messaging queue, you can use database, you can use anything to hold the state if you really desire it. And you have to think in terms of user experience point of view as well. Based on your requirement, you can design your system in such a way that user will not even get to know something is down. I can take another example from Amazon itself. Let's say in your Amazon you are shopping, and you want to see the reviews, and suddenly review service goes down. You cannot stop the website on for this, right? So in that case, what you can do is you can take one of the approach. Either you can show, you can just hide the review section, and people, okay, review is not there, I think no one has reviewed, and they can take a call on their own, and they can decide whether they want to order or not. Or you can show some average reviews. Let's say you are showing some average reviews, and in reality review is lower or down. It can basically as soon as service comes up, it will basically auto correct and auto adjust. So I think I'm done. Thank you everyone.
I hope you found today's event to your liking. Thank you once again, everyone. We wish you a productive and a fulfilling year ahead. Stay healthy and stay safe. Thank you.